Okay, we've looked at how we can find measurements of angles if we know that there are parallel lines cut by a transversal, but we also have some converse theorems. The converse, if you remember, are where you switch the hypothesis and the conclusion. So you switch the if and the then part. So the other day we had if you have parallel lines cut by a transversal, then you know the angles are congruent or supplementary depending on which angles you were talking about. But now we have if the angles are congruent or supplementary, then we know that the lines are parallel. So it's essentially going backwards of what we did the other day. So when I say converse, you're thinking we just switch the x and the y. So first we have the corresponding angles converse. So if we have two lines that are cut by a transversal and we know the corresponding angles are congruent, then we know the lines are parallel. So again, we're going backwards. So we have if we know that these are congruent, then we know that the lines are parallel. Remember that the arrows on the parallel lines or on the lines mean that they are parallel. Okay? So if we know the corresponding angles are congruent, then we know that the lines are parallel. And then we have the same kind of backwards scenario for all the ones that we had the other day. So we have not only the corresponding angles, but we have the alternate interior angles. So if the alternate interior angles are congruent, then you know that the lines are parallel. We also have the consecutive interior angles. So if those are supplementary, this is our one that's supplementary, not congruent, then they're parallel. Remember, we have two other names for this. We've got this could be co-interior. We also have that this could be same side interior. So you need to be familiar with all of those. And then we have our last one is the alternate interior angles converse. So it's saying if the alternate exterior angles are congruent, then the lines are parallel. Now we also have this other theorem. This one, this name is one that I made up. It's not one that's normally in books when you have theorems and there's not a name that's known in the math world. They just name it according to whatever chapter you're in. So like this would be chapter 3 and then point 1, so theorem 3.1. So I just named it parallel to the same line theorem. So this says if two lines are parallel to the same line, then they are parallel to each other. So this would be if we have two lines are parallel to the same line. So we know this line is parallel to this line, but we also know that this line is parallel to this line. Then we know that these two lines are parallel. So we know those two lines are parallel, which should make sense to you. Okay? But that's our parallel theorem, or parallel to the same line theorem. So if we take a look at some examples, okay, so this one says find x so that u and v are parallel. Well, first of all, if we think about what u and v are, or u and v are the two lines. So if we want those to be parallel, we have this angle here and we have this angle here. So those two angles, they are on the opposite sides of the transversal. Remember that this purple line is your transversal. So now notice on this picture that we have no arrows to show that these lines are parallel. So we're trying to show that these would be parallel if these two angles or something. So these two angles are on the opposite sides of the transversal and they're on the exterior. Remember that this is the interior of the parallel lines and then that this is the exterior. So these two angles, the relationship that we call these two angles, are alternate exterior angles. Okay, so what we can do is we can use the alternate exterior angles converse theorem that says if the two angles are congruent, so if your alternate exterior angles are congruent, then the lines are parallel. So if we want the lines to be parallel, which is what the instructions say, we need 110 to be the same as x plus 120. Well, now I can solve this. So to get the x by itself, we're just going to subtract 120 from both sides. So then we get negative 10 equals x. Now I go back and I check my instructions. It says to find x so that u and v are parallel. I found x, so that's the end of my problem. Okay? So we're going to look at this problem over here to the right. Same set of instructions. We have lines u and v, and we want to find where what makes that value of x so that u and v are parallel. Well, again, if we look, our purple line is the transversal. I really wanted that on highlighter. Our purple line is the transversal. Okay, so we're on opposite sides of the transversal. That means that it's alternate. Again, if we look, this is the interior. Oh, I want highlighter. Struggling with my highlighter versus non-highlighter today. This is the interior of the lines, and then we also have the exterior up here. So the two angles that we're looking at are on the interior, so this is alternate interior angles. So when we have alternate interior angles, there's a theorem that says if those two angles are congruent, then we know the lines are parallel. Okay? Now notice we don't have parallel lines given to us, right? There's no arrows on u and v that show that they're parallel, right? So that means that if I have these two angles equal, then they will be parallel lines. So if I set 9 plus 8x equal to 65, that will get it so that u and v are parallel. So I'm going to subtract 9. So we get 8x. When we subtract 9, that gives us 56. So I want to undo multiplying here. So we undo multiplying with dividing. So we get x is 7. Okay. Now, if we look at this, it says if A is parallel to B and B is parallel to C, what can you say about lines A and C? Well, okay, so we know A is parallel to B, and then we also know that B is parallel to C. Now, I used 2 arrows on the B and C because I had already used 1 arrow on A and B. Well, if we know, there's a theorem that we had. If we go back up and we look at it, it says if 2 lines are parallel to the same line, then they are parallel to each other. So parallel, if A and B are parallel to C, so A is parallel to C and B is parallel to C, which is what was given, then we know that A and B are parallel. So we also know from our theorem that, I'll put it over here, these are parallel lines. So we can say that A is parallel to C. Okay? So those are some things that we can do. So remember, I didn't give an example of each kind, but that's the idea behind proving lines are parallel, is that you want to remember if you have congruent alternate exterior, alternate interior, corresponding angles, then you have lines are parallel. Or if you have your supplementary angles are your consecutive interiors, one name for it, your same side interiors, another name for it, or your co-interior angles is another name for it, then if those angles are supplementary, then the lines are parallel. Okay, so you should be starting to remember those relationships with those angles. And that's how you can show that lines are parallel.